Hello, welcome to BL Videos. You may be wondering how to derive the formula to find the day of any date of the calendar. So, in this video, you will learn to derive it with simple basic concepts. Let's start with the simple concept. Suppose you are given the month from a certain year, and if you know that the day before first of that month is Tuesday, on which day does 25th of that month fall? Let's assign values 1, 2, 3, 4, 5, 6 and 0 starting from Monday to Sunday. Then the day before first of that month is Tuesday, whose value is 2. Let's see the shaded boxes. Here 2 plus 1 equals 3, 2 plus 2 equals 4, 2 plus 3 equals 5 and so on. As a generalization, we can add 2 and the date 25 to get 27 as the day on which 25 of that month fall. Since the days repeat in 7 days, we divide 27 by 7 and find the remainder as 6, which is Saturday, the required day. So, we got the formula for day as month code plus date. Saying month code, I mean to say the value corresponding to the day before the first of that month. When you get the value of more than or equal to 7, you can simply take their remainder by 7 to get between 0 to 6. The same concept is applied for whole year, say year of 1988 AD. If you know the month code for all the months, then you can easily find the day for any date of that year. So, we extract all the month codes for each month for the year 1988 as shown, and then we can find day of any date for that year. But the question is, how to do it for other years? To find the answer, you should know that the calendar repeats itself in every 28 years. I mean to say that the calendar of 1988 AD is same as that of 1960 AD and the same as that of 1932 AD and so on. When you go on subtracting, you will finally reach to the year 0. So, I have chosen the year 1988 AD because it is same as 0 AD. Now, let's write the month code for 0 AD as shown, and I have also extracted the month codes for 100 AD. I mean to say 1 century later because we want to correlate the month code and the century. We find that each month code decreases by 1 after 1 century. Similarly, I extracted the month code for other consecutive centuries also, and they also show similar pattern. That is, how many centuries are passed, the month code decreases by the same number. After 20 centuries, the code also decreases by 20. As a generalization, we can say that we also need to subtract the century to find the day of any given century. Then the formula becomes day equals date plus month code minus century code. Up to now, we have only talked about date, month and century. Now, we need to correlate the month code and the year. Saying year, I mean to say only the last 2 digits of a year. Let's write the month codes for 0 AD again. And we also write the month code for 1 AD as shown. We find that each month code increases by 1, except for the month January and February, so we put red mark on it, as shown. Similarly, from the month codes of 2 AD and 3 AD also, we get the similar pattern that each month code increases by 1. But in 4 AD, we find that the month codes increase by 2, except for January and February, so we keep red marking these 2 months as shown. Analyzing the month code for other consecutive years, we find the similar pattern in them. That is, in first 3 years, the month code increases by 1 and in the last year, it increases by 2, except for January and February. To make January and February compatible with the above rule, we state a rule, that is, subtract 1, whenever the month is January or February and the year is leap year, and we add 1 to the codes marked in red, as shown. Similarly, we add 1 to each code in the red portion, and now the rule is applied for all months including January and February also. But, since we have made correction for January and February, I call the term the JFL code, or the January-February leap year code. JFL code equals 1 if the month is January or February and the year is leap year. Let's conclude, in every year the month code increases by 1, so you also need to add the year to find the day. In every 4 years, the month code again increases by 1, hence you also need to add 1 in every 4 years. In other words, you also need to add the number of leap years. For instance, if the year is 15, then divide it by 4, to get the quotient as 3, and this 3 will be your number of leap years. And, we also corrected the month codes for January and February when the year is leap year, hence we also need to subtract the JFL code to find the day. After this you only need to remember the month code for 0 AD as shown. Finally, we found the formula to find the day as month code plus date code minus century code plus year plus number of leap years minus JFL code. But, remember that the year plus number of leap years is equivalent to negative of year code found from odd plus 11 rule. Hence we replace it by minus year code. For your information, the odd plus 11 rule is recently developed method of calculating year plus number of leap years in faster way. For details, you can see my videos, given in the description below. Finally, day equals month code plus date code minus century code minus year code minus JFL code, and finally take the remainder by 7. There you go, we have derived it. Thanks for watching. Be imaginative and be logical.